Okay, I want to talk about some little review and then get into some other concepts here. Let's talk about 1 over cosine, which is the secant graph. Okay, so one way to do this, let's graph cosine, and here's my unit circle. When I go clockwise around the unit circle, it's basically starting from 0 and going here. And when I go negative around the unit circle, starting at 0 this way, it's going here and going negative. So I'll draw a quick cosine graph knowing that I'm what? Cosine is 1, 0, negative 1, 0, 1, 1, 0 at pi halves. This is pi halves in between the 2 pi. Okay, so 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1, and so on. Going this way, negative, it's start off at 1, 0, negative 1, as I go over here, 0, 1. So here's my cosine graph with no shifts, vertical shifts, horizontal shifts, normal amplitude. Here's my 1 and negative 1 here. Negative 1, and this is 1. Okay? Alright. Remember, 1 over cosine of x is secant x. So cosine can't be 0 because we can't have 0 in the denominator. Where are we 0? At pi halves, and every increment of pi halves. Pi halves, 3 pi halves, 5 pi halves, 7 pi halves. Okay? Because 1 pi, 180 degrees, is 2 pi halves. What's 2 pi halves? That's 2 over 2, which is pi. Okay? So here's my asymptotes. Here, everywhere cosine is 0. Okay, and something I said in my previous video, I believe, and in class was wrong. I caught myself. I was just making sure reading up on things, and not just shooting from the hip. It was about the period. Okay, no, we know that the period of cosine is 2 pi. It takes here from 0 to pi back up to 2 pi to do a whole cycle. That's also going to be the period of my cosine. All right, my secant of x equals 2 pi. Okay, because 1 over my graph will look like, let's say, from here from pi halves to 3 pi halves. Okay. In fact, let me do a little. Maybe my asymptote's a little darker here in brown. Okay, so here's pi halves to 3 pi halves. From here to here is an interval. Okay? Notice, 1 over negative 1 is negative 1. And as these values get smaller or less negative, 1 over those values, 1 over a fraction becomes bigger. And I approach this value here. You approach the asymptote, but you never touch it because you can't have anything on that. The asymptotes block out that graph because you can't enter what will get you 0. So there is no entry there for your input, so you have no output there. Okay? 1 over 1 is 1, and 1 over fractions gets bigger. 1 over fractions gets bigger. So this is a complete cycle. Notice it goes from asymptote to asymptote, but notice this doesn't repeat itself. I've got the frown and the smile. So the period of a secant is 2 pi. Here's pi halves, the 3 pi halves, 2.5 pi. That each of those increments is pi, and it's 2 pi. Okay? So you draw your cosine curve, and here would be 1 over 1, and so on. Okay? So the period, and let's start thinking about the period is 2 pi for a normal graph. All right. We're going to have the same type things going on here, like A secant B x plus or minus your C phase shift plus or minus your D. Okay? Okay? So things to think about are amplitude, your period B. It'll affect where your, this can affect where what? Where your asymptotes are going to go. The best way to handle that would be, one, plot your cosine for the new period. Plot your cosine first, as we've been doing, and then where it's 0, plot your secant. Let's take a look at that real quick. Let's do cosine of 1/2 x, or rather, let me change that up. What I meant to say was, let's do secant of 1/2 x. So as I graph this, pi, 2 pi, 3 pi, 4 pi. B is 1/2. My period for secant is still 2 pi over B. 2 pi over 1/2, we know, is 4 pi. Okay, so remember how I did this. I'll just put my bookends here at 0 and 4 pi, right? Okay, so cosine we know is going to be what? On our unit circle, we start out at 1 and finish at 1. Okay, in the middle it should be -1 and back. So where's the middle? The ends of my graph should be, here's 1 and 1. The middle of my graph now is right at 2 pi. That's where -1. In the middle of each half for the cosine is my 0. So at 3 pi and 1 pi. So here's my new graph for cosine with a period of 4 pi. So for secant, my asymptotes again are where? Where cosine is 0. Okay? So I'm going to have to make this graph like so. And it looks like I'll need to kind of extend this to 5 pi. Okay? And have this come on down right there. Okay? So here would be another asymptote, and here is the positive smile on my secant graph. So notice now the period of my secant, for me to get a frown and a smile, is no longer 2 pi, but it's 4 pi, just like it was for cosine, okay? So that's going to apply also for cosecant. The period for cosecant, how much time do I have here? 8 minutes. Okay. This type logic's also going to apply for cosecant. Okay? Draw your sine curve. For a normal, here's pi, 2 pi, 3 pi, and okay, here's this is my sine graph. So for cosecant of x equals 1 over sine. Notice how I graph my sine curve. Where's sine 0? That's where my asymptotes are going to go at pi, okay, and 3 pi. All right, and we can do the same type thing if we have a change in the period. But right now, cosecant is 1 over sine, so 1 over all these values. The smallest value I have is 1 over 1, and then 1 over fractions. And down here, the smallest negative is -1, and then it gets very negative here as 1 over, these number values get small, 1 over that becomes very negative, okay? Notice my interval is 2 pi. For me to get a smile and a frown is from 0 to 2 pi, okay? So for cosecant and secant, the period is 2 pi, just like it was for cosine and sine, okay? All right. Things to always think about are your period, your domain, your range, and where your vertical asymptotes are. Okay? Okay? So your domain will be everything but where the asymptotes are. Your range is going to be, in this case, from 1 up or from -1 down. One way to write that would be y, the absolute value of y is greater than 1, okay, for my range, okay? But those are things we're always going to address where your vertical asymptotes would be. That means your domain is everything but where those asymptotes are, okay? Okay, I got right now, I've got the tangent function drawn, okay? Notice that in red are the asymptotes, okay, if you can see this. Here is 0, here's pi, the asymptotes are at pi halves. Remember, this is sine, tangent is sine of x over cosine of x, okay? Where is sine 0? It's okay to have sine as 0. Sine is 0 at where? Pi, 2 pi, 3 pi, 0. Okay? Where is cosine 0? Intervals of pi halves. So notice the asymptotes at pi halves. Here's 3 pi halves, 4 pi halves, negative pi halves. Where's cosine, or where's this tangent 1 and negative 1? In intervals of pi over 4. If you look at the unit circle at 45-degree reference angles, pi fourths, 3 pi fourths, 5 pi fourths, 7 pi fourths, cosine and sine are the same. Positive 1, negative 1, positive 1, negative 1. Okay? In quadrants where they have the same sign, your cosine is, or your tangent is 1. And where you're in quadrants 2 and 4, where you have different signs for sine and cosine, it's negative 1. So notice where intervals of pi over 4, it's 1 and negative 1, 1, negative 1, 1, negative 1, so on. Okay? As we approach pi halves, sine gets very big and cosine gets very small, approach infinity. As we approach, that's as we approach pi halves this way, okay? And we're on the other side of pi halves in quadrant 2. We've got a negative over a positive. A different signs. Cosine's negative, and it's going to, so as sine gets very big and cosine gets very negative small, it approaches negative infinity. At pi, sine is 0, and as we approach negative 3 pi halves, notice, remember, in this third quadrant, sine and cosine have the same sign, so it's going to be negative over negative is a positive. As sine gets very big and cosine gets very small, approaches infinity again. So there's your cosine, or your, that's your tangent function, okay? All right? When we start changing the period, we start period, it's going to be a little different. The period here for one complete cycle for tangent or cotangent is just, the period is pi. To determine a period, it's pi over b, not 2 pi over b, okay? All right, that's about it. I'm going to go for this video. We're going to go into these graphing more as far as effects like cotangent of 1/4. We'll make bookends and do the same thing and find where our values are 0. But notice the middle of each graph for tangent is what? Is going to be for this thing is right in the middle of the graph. Right in the middle of the period as we go through 0. The middle of the other two halves are going to be 1 and negative 1. So it'll be easy to draw a graph once we figure out where the bookends are. But remember, the period for tangent or cotangent is pi over b. Okay? All the other ones have intervals cosine, sine, secant, cosecant have intervals of 2 pi. Tangent, cotangent, tangent, cotangent, pi is your period. Cosine, sine, secant, cosecant, 2 pi. And that's determined by either 2 pi over b or pi over b for tangent or cotangent. Okay? All right, we'll work more of these problems.